Okay, so hopefully that video gave you an idea of how big a mole is, right? So just to add on a layer of that, a fun fact, did some fun math. If I gave you 1 mole of pennies, or 602 sextillion pennies, if you want to figure out how much money that is, that's this much money, right? And now, another question, because this much money might be hard to conceptualize. You might be like, oh, it looks kind of small, Miss Kwan, right? So, how many years will it take for you to spend it at a rate of $1 billion per second? So, if you spent $1 billion per second of this much money, how long will it take for you to spend it all? So, if I have $1 billion, that's this much in scientific notation, right? There are 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 365 days a year, doing all of this math. Here, it's going to take me 190,000 years to spend all of this money if I'm spending it at $1 billion per second, right? So we would all be dead if we're spending $1 billion per second. That's a lot of money, right? So it's just to show you how huge this number is, mainly because we're working with atoms and molecules that are very, very tiny, so we need large amounts of these elements. Okay, so let's not talk about moles for a second, and let's go back to a dozen, right? So if I have 2 dozen of these things, how many molecules will you have? Well, a dozen is 12, so you might be able to solve this in your head and tell me that, oh, I'm just going to have 24 of the NH3s, right? And if I have 2 dozen, it's just 2 times 12, right? Because 1 dozen equals 12 things, right? And if I said, okay, what if I asked you the opposite? What if I asked you 36 NH3s is how many dozens of NH3s? Well, this might feel a little bit harder, right? But if we're multiplying by 12 to get the amounts of them separately, we're just going to do the opposite, right? So if I have 36 NH3s, I'm just going to divide by 12 to get how many dozens of things I have, right? So 36 divided by 12 is going to be 3 dozen, right? So if I'm figuring out from dozens of things to the number amount of each thing I have, I'm going to multiply by 12. And if I have the number of something and I want to figure out how many dozens they are, I'm going to divide by 12, right? So mathematically, this is what I'm doing for the number dozen. And this is pretty much what we're doing for moles. We're either multiplying or dividing. Okay, so let's do a practice problem with moles together. So recall that 1 mole is 602 septillion of something, or 6.02 times 10 to the 23rd of molecules, or atoms, or anything. Right? So the 2 things you definitely need to know and write down is this part. So I didn't write it in red, but mainly you need to know that if I'm going from number of moles to atoms or molecules, I'm taking the number of moles and multiplying it by 602 sectillion, and that will give me the number of molecules or atoms. If I'm given the number of molecules or atoms, I'm going to divide by 602 sectillion to figure out the number of moles, right? Same thing that I did mathematically with a dozen. Okay, so here, given 2 moles of NH3, how many molecules of NH3 do you have? So I need to pay very close attention to what I'm given and what the question is asking, right? So know that I'm given a number in moles, specifically 2 moles, right? And the question, or what I'm trying to find, is how many molecules. So I'm given moles, I'm trying to find molecules. So which one of these two do we need to do? Well, if we're looking for molecules, right, this one equals number of molecules or atoms, right? So that's what we're looking for. So we want to use the first equation, right? We're not trying to find moles, so we're not going to use this one. We're trying to find molecules or atoms. So in this case, following the equation, right, how many moles am I given? I'm given 2. So I'm going to times 6.02 times 10 to the 23rd, and that will equal how many molecules or atoms I have. So the tricky thing about this one is using my calculator. So I just like to pull up the calculator from Google. You search Google Calculator, and this will pop up, right? Okay, so I just need to type this in. And since this number is pretty big, when I type this in, I'm actually going to put parentheses around this just to correct for any possible error. Always do that just in case. Okay, so let's type everything in. So we have 2 times 602 septillion is 6.02 times 10, and then exponent. So to get to exponent, I'm going to click on this one. 10 to the power of 23, close parentheses, equal. So I get this kind of weird looking number, 1.204 e plus 24. So let's translate that a little bit. So this number basically means 1.204 times 10 to the power of 24. So the e plus, this part, is just the times 10, right? And 24, my exponent, is this one here. If I were to write this out in standard notation, so the regular way that we normally write numbers, it'd be 1. So after this decimal, it's 24 spaces, right? So 204, that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. This many zeros at the end, and then a decimal. I ran out of room. So instead of writing it this way, you can just write it out this way as it shows up on the calculator. So my answer for this one is going to be 1.204 times 10 to the 24th. Doop doop. Box my final answer. So for these, I would also write down an example problem of what buttons to press in the calculator if you're not super familiar with it. And if you are, then don't worry about writing it down. Okie dokie. So what if I have this particular example given 1.806 times 10 to the 24th molecules of NH3? How many moles of NH3 do we have? Right? So here, what are we given? And what are we trying to find? Well, we are given 1.806 times 10 to the 24 molecules of something. So I'm paying attention to the unit or the word at the end, molecules. And it's asking me how many moles do I need? Right, so I'm looking for moles. So if I'm looking for moles, this one is equals molecules or atoms. This one says equal moles. So I'm going to use this equation because I'm looking for moles. So my given is 1.806 times 10 to the 24th. Just going to put a parentheses around that so I know that this is one number. And then I'm going to divide it by 6.02. Oops. Times 10 to the 23rd. This number is really ugly. It's basically me rewriting this number in parentheses. So in my calculator, I'm just going to type this in. Okay, so let's clear everything first from the last problem. So open parentheses 1.806 times 10 to the power of 24, close parentheses, double checking. So that's my first number here in purple. This time I'm going to divide by my mole, 6.02 times 10 to the 23rd. So open parentheses, 6.02 times 10 to the 23rd equals 3. 3 moles is what I get. So here, how many moles is this huge number? Well, it's going to be 3 moles of NH3, much like 3 dozen of NH3. At this point, feel free to try the practice problems on the next slide. If you are new to scientific notation and still a little confused by it, feel free to let me know.